Hey everyone, so I just wanted to do a quick video demonstrating an example of how you could go forth completing one of the questions from the atmospheric circulation lab. In particular, number 7 of the additional questions. So I ask you what it means to be in geostrophic balance, and then I ask you to sketch a scenario where there's a parcel of air in the middle of the troposphere. So I say that we're not at the surface, basically, that is initially at rest, and then I want you to show the process of the parcel going into geostrophic balance, and I want it to be in 4 panels. So what I have here is I'm starting, I have the Google Jamboard here, and I'll keep this one up and available for you to kind of reference, I suppose, if you'd like. And I guess in the directions I don't say, like your things, but you'll have the recording as reference. Actually, lied. I'm gonna delete when I do the when I'm finished with this, I'm going to delete the Jamboard because I want you all to sketch it on your own. And there are several resources available to you that are examples, aka the slides. Anyways, so I want you to initially start as a parcel at rest. So that's what this lovely little blob here is. And the first step is to identify the direction of the pressure gradient force. And you'll see here that I have indicated heights. And I have 2 heights here. I have 5,980 decameters. That's just like an order of magnitude larger than a meter and 2 orders of magnitude less than a kilometer, just by the way. And then 550 decameters here on the bottom. So which of these numbers is larger, aka which height is greater? You can think of pressure and height in the same vein, by the way, when I talk about pressure gradient force. So think to yourself, which one is higher? Okay, we've thought. Then we know that 5,980 is higher. Thus, my pressure gradient force arrow, my vector, is going to point from high to low. That's just the that is the rules here. Oh wow, it's bright green. So that's where my pressure gradient force is going to point. And then again, I assume we're in the northern hemisphere here, right? So assuming northern hemisphere, then what direction will my Coriolis force arrow point? Northern hemisphere, we would assume to the right. Correct? But I'm not moving very much. So my Coriolis force arrow, in comparison to my pressure gradient force arrow, is much, much, much smaller. Right? I even said we're assuming we're at rest, right? So because my pressure gradient force arrow is so much larger, then I'm going to start to move because now I have a net force acting on me, right? Again, thinking back to that idea of Newton's laws, right? So now I'm kind of in motion. So now I'm going to be kind of up in this direction for my second panel-ish, right? So I've moved a little bit. I've kind of gone a little bit more towards the bottom of the page and a little bit towards the left, right? But my pressure gradient force is still going to be pointing the same direction and roughly the same magnitude. But now that I am actually moving, so now I'm saying that my wind is kind of starting to go this way. My little black arrow here is wind. Thus, my Coriolis force is starting to increase as well. So that's what I'm trying to indicate with this larger arrow here. But we're still, oh, sorry, actually, shoot. So it's no longer directly to the left now, right? So we have to go at a 90-degree angle from our actual direction of motion. So we're almost in balance, but we're not quite there yet, right? Our pressure gradient force arrow is still dominating here. Yeah, but we're getting closer, getting closer. So now down on my third panel, we could say that it's kind of hard to tell now how much farther I'm going to be going up and to the left, but say now I'm up and around here, right? My pressure gradient force again, still pointing the same direction and roughly same magnitude. I realize that I'm going off of the page now, so maybe in your sketch, maybe don't start in the middle of the page. But I'm still not quite in balance yet. We're getting there, but almost. So I'm not quite there, but almost there. But still my Coriolis is growing because my wind speed is increasing as I continue to go. And then by my fourth panel here, I'm just going to move a bit more back, sorry, but so now I've moved quite a bit, but my PGF is here and my Coriolis is here, and I'm trying to make these arrows the same size, indicating that they are of the same magnitude. So I'm just going to put a little key here just so you can, if you would like to refer to this later or while you're referring to it perhaps in the thing. So red is Coriolis. Oh, come on. Gosh dang it. Red is Coriolis. Green is PGF, and black is parcel / direction of motion. So that's kind of what's going on there. So again, we started as a little parcel. Again, I probably would have started a little bit closer to the top here. So started as a parcel, not quite in motion. First thing to do is identify the pressure gradient force. Next thing to do is identify the Coriolis force, determine which force is dominating at that time, then start moving in that direction of motion. And then as you start to move, you're starting to likely move a bit faster than when you started at rest, right? So then your Coriolis is going to increase and your pressure gradient force is still going to stay the same because I did not give you a situation where your pressure gradient force is increasing or decreasing, right? So try to keep that arrow the same size until you finally end in geostrophic balance. Okay, so now you have a short, quick video to reference. You also have slides from various lectures to reference as well. Reach out to me if you need any help with this. I'm happy to try and walk you through it as best as I can. So if you want to utilize the Jamboard that's on iLearn, you can maybe even use it as your sketch, or you can just sketch this by hand. That works for me as well. So with that, yeah, let me know if you have any questions. Thanks for watching.